Next, we're going to learn how to write an equation of a polynomial given zeros. This is very similar to writing the equation of a quadratic in factored form. Starting off, we have our function equal to, and in this case, because you weren't given an additional point, you can choose any a value you want to. Choosing 1 would be the easiest a value, so I will do that. Sub your zeros into the binomials with the x and make them opposite. So the -2 becomes positive and the -3 becomes positive. Then multiply and distribute as much as you can. X minus 0 I'm going to simplify, and I'll FOIL my x plus 2 and x plus 3. So we get x squared. The 3x and the 2x combine for 5x, plus the 2 times 3 gives me 6. Finally, I will distribute my x. This is one example of an equation that has the given zeros. If you had used a different a value, you would get another equation with the same zeros. Our next example is slightly more complicated. We have a single zero that is 1 minus the square root of 2. Notice off to the right in red, it says that radical zeros as well as imaginary zeros always come in pairs. So we will use, in this case, the conjugate for the root as well. So we also have the root 1 plus the square root of 2. This one especially is complicated enough without choosing an a value other than 1. So I'm going to stick to 1. I have a 0 of 0, subbing that in. For these, make sure that when you subtract that root, you put it in parentheses. We'll have to distribute that negative sign before we multiply. Same thing for our other root, our 1 plus root 2, we'll have to distribute that negative sign. There are two ways to multiply these out. I'm going to show you the way that I think works best for most students, and that's distributing the negative sign. And instead of FOILing, because FOIL only works if you have binomials, we will have to, I just call it distributive property. You distribute until you are done distributing with each term. I'm going to leave my first x alone, and I'm going to multiply my two trinomials together first. So I have x times x gives me x squared. Then I have x times -1 and x times negative root 2. Now I will distribute my -1, so I'll have negative x plus 1 plus root 2. And then I will distribute my root 2, so I'll have a positive x root 2 minus the square root of 2 minus, we have the root 2 times root 2. The square roots cancel, leaving us with just the 2. Remember when we did the difference quotient and all of the terms without an h canceled? For this, all of the terms under a radical should cancel. So we have negative x squared of 2 and positive x squared of 2 canceling. We have a positive root 2 canceling with a negative root 2. Keeping that x out front and combining any other like terms, we have x squared minus x is negative 2x. Negative 2 plus 1 minus 1. Finally, we'll distribute that x and finish off our polynomial. And the final piece we're going to learn is the intermediate value theorem. When you read the words, it sounds highly confusing, but it's actually very simple to apply. The way that we're going to use the intermediate value theorem is that if there is an x coordinate, for example, -1, and the y coordinate is negative, and you have another x coordinate nearby, in this case we're going to say 0, and the y coordinate is positive, then it has to cross the x-axis between these 2 points. So we know a 0 will occur somewhere between an x value of -1 and an x value of 0. So let's take a look at how this works. We are asked to show that there is a 0 between -1 and -2. When it's giving you those values, it is telling you those are x values. So we're going to sub those x values into the equation. I'm going to start with the smaller x value because I like to go in order. subbing in that -2 everywhere there's an x. Be very careful with order of operations on this one. -2 cubed gives us -8. -2 squared gives us +4. -8 plus 4 is -4 plus 1 is -3. So we have a negative y value at -2. This would be the ordered pair -2, -3. Second, I will sub in -1 everywhere there's an x. Again, being careful with those negative signs. -1 cubed is -1. -1 squared is 1. -1 plus 1 is 0, plus 1 is 1. So we would have the ordered pair. Our x value is -1, and our y value is +1. The second step, it says graph for visual confirmation. Notice that the y value went from a negative to a positive, so it must have crossed the x-axis somewhere between. I'm going to scale each of these by 1. So I'm going to call this graph -5 by 5, plotting that -2, -3 value, and our value of -1, 1. Because this graph is continuous, we know it's a cubic function. Leading coefficient is positive, so we know it rises. Might have a bump in the middle. We do not need to graph this very accurately, but we know the graph will do something like this. And we can clearly see that it crosses the x-axis because you cannot pick up your pencil to draw the graph. To go from a negative y value to a positive y value, your graph must cross the x-axis. So there must be a 0 somewhere in between those two values. This time we have the graph, and we are just going to say which two x values does the 0 occur between. Our first 0 occurs between -2 and -1. Our second 0 occurs between 0 and 1. Our third 0 occurs between 1 and 2. And our last 0 occurs between 3 and 4. Notice we gave 1 unit intervals. So the distance between those two x values that I wrote down is 1 unit.